Hi, I'm Giovanni, and I'm here to explain to you why water potential is needed and how it's calculated. This paper slide video was made by Dakota and me. The formula you need to find water potential will be solute potential plus pressure potential, as shown in this equation right here. To find solute potential, you will need this formula, negative times I times C times R times T, where I would be the ionization constant, which is the amount of particles broken down by water in a solution, such as NaCl will be broken down into 2 particles, and glucose, which is a sugar, cannot be broken down by water and will stay as 1 particle. C is the molar concentration, which is stated in an equation such as 0.2 molar concentration or 0.1 molar concentration. R is pressure constant, which is always 0.0831. And T is the temperature constant, which is given to you in Celsius or in Kelvin. But if it's given in Celsius, then you need to change it to Kelvin by adding 273 to the amount of Celsius provided. Which way does water move? Water moves from a high to a low concentration. In this picture, you can see a cell has a water potential of -4, and the water has a water potential of -6. So since the water potential is higher in the cell, water will move out of the cell into the water. Vocabulary. 3 words you would need to know for water potential would be hypertonic, hypotonic, and isotonic. Hypertonic means when a solution has more solute, but it has less water, and hypotonic means a solution has less solute, but more water. Isotonic means a solution has equal amounts of both solute and water. This is a sample problem. A cell has a 0.2 molar concentration solution of sucrose at 40 degrees Celsius with a pressure of 2. The cell is placed in a 0.1 molecular solution of glucose at 40 Celsius in an open beaker, which will water flow. So first you need to calculate the water potential of a cell, such as using this equation right here. By finding the solute potential, you would need negative times 1, which is the amount of particles which sucrose is broken down to. Since it's a sugar, it cannot be broken down. 0.2 moles per liter, which is the molecular solution concentration, and then multiply that by the pressure constant, which is always 0.0831, and then finally adding the Celsius plus 273 to get Kelvin. Once you multiply all that together, you should get negative 5.2 bars. And since it has a pressure of 2, then you add the negative 5.2 plus 2 to get negative 3.2 bars, which that would be the water potential for the cell. Then you will need to calculate the water potential of the solution that the cell is placed in, which is negative times 1, because this is a solution of glucose, which cannot be broken down by water. Then you multiply that by the pressure constant of 0.0831 times the temperature, which is 40 degrees Celsius, but you will need to add 273 to it to get turned into Kelvin. Multiplying all that together will get you negative 2.6 bars. Since it is an open beaker, it has no pressure at all. So it will be negative 2.6 plus 0, which would be negative 2.6 bars water potential for the solution. So since the higher concentration is in the solution, then the water will flow into the cell since it has a lower concentration. Second sample problem. A cell has a 0.2 molecular solution of NaCl at 23 degrees Celsius with a pressure of 3. The cell is placed in a pure water solution at 23 degrees Celsius in an open beaker. Which way would water flow? In this previous solution or problem, you need to use the same equation to calculate the water potential of the cell. The solute potential of the cell is negative times 2, which is NaCl broken down by water, which can be broken down to 2 particles. Then multiply that by 0.2 molars, which is moles per liter. Then multiply by the pressure constant, which is 0.0831. Then multiply that times 23 Celsius plus 273. It would be 296. The solute potential will be negative 9.8 bars. And since you have a pressure of 3, the water potential will be negative 9.8 plus 3, which is negative 6.8 bars. That's the water potential of the cell. Now you need to use the same equation to find the water potential of the solution that is put in, which is pure water. Since it is pure water, it has 0 for ionization constant and 0 for molecular constant. Multiply that all together, it gives you negative 0 bars, or 0 bars in total. The water potential of the solution will be 0 plus 0. Since it's an open beaker as well, you have 0 water pressure potential, which is 0 bars. Since the water potential is higher outside, the water will flow into the cell, since the cell has a negative 6.8 bars water potential. Osmosis in plants and animal cells. Osmosis in plant cells are good for plant cells, since the plant cells cannot burst due to the cell wall. It has a large vacuole to hold the water that is flowed into the cell. And for animal cells, water flows in will cause the animal cell to burst, or this contractile vacuoles will flow the water out of the cell so it won't burst. But either way, it is better for a plant to conduct osmosis. Thanks for watching, guys.